Understanding the weather is crucial for every sailor. A solid grasp of meteorology and understanding weather forecasting is a valuable and key skill that will make your sailing safer and more enjoyable. Meteorology is a vast topic. Like eating an elephant, we'll tackle it bite by bite. Let's get started. This video is the first bite of the weather elephant. We will look at heat and global circulation, the four elements of weather, global winds and jet streams, sources of weather forecast, definitions in weather forecast, and types of clouds. Heat is the most important factor that drives our weather system. The Earth is heated by solar radiation. Most heat is absorbed at equator, and as we move towards the pole, less heat is transferred from the sun to the Earth. As we get to 40 north or south, then the heat radiating away from the Earth is more than the heat coming from the sun. So our weather system is actually like a big AC unit, taking the heat from the hot areas around the equator to the poles. If we didn't have the weather systems and the winds, the poles would get so cold that nothing could live there. And equally, the areas around the equator would be so hot that nothing could live there too. The purpose of global circulation is to redistribute the heat. We have a three-cell circulation system that exists in both the northern and southern hemisphere. The largest cells are the Hadley cells. At the equator, the warmer, less dense air rises. Then the warm air spreads towards the poles, gradually cooling and sinking as it moves, flowing back to the equator. The smaller cells are the polar cells. Cold, dense air descending in the polar regions flows to 60-70 degrees north or south, where it starts to warm up and rise, returning to the poles at higher levels. The Ferrier cells are not driven by temperature. They flow in the opposite directions to the Hadley and polar cells, acting like a gear. The cells are resulting in semi-permanent low and high pressure areas. When air is rising, an area of low pressure is created. This area gets much more rain. That is why the largest area of rainforest are found near equator. Where air is descending, an area of high pressure is formed, giving largely clear skies and little rain, which leads to the desert regions. The four elements of weather are temperature differences, that means hot and cold areas, atmospheric pressure, air pressure due to the density of the air. We will look at that in more details shortly. The winds affects the weather system and global distribution of heat and precipitation. Humidity is how much water is in the air. It's like the hot, moist air in your bathroom that condensates as the air cools. We'll have the same in the spring when hot, humid air is coming from the southwest Atlantic Ocean into the cold waters of the English Channel. It condensates and creates sea fog that can last for days. Let's have a look at the mechanism that creates high and low pressures. The sun radiation heats the surface of the earth, and the warm earth heats the air above. Then the warm air rises as the air molecules get further apart, creating a low pressure below. That is the same principle we see in a hot air balloon. We heat the air inside the balloon, and the air molecules get further apart, taking up more space, and the balloon rises. This process gives us the temperature and pressure cycle. The hot air rises, creating an area of low pressure. As the air rises, it cools down and it puts down towards Earth's surface, creating an area of high pressure. The cooler air then flows across to replace the hot air, and we have the temperature pressure cycle. You have probably experienced this cycle when you've been to the beach. In the morning, the sun heats the land, and then the land heats the air above, and the hot air rises. The cooler sea will then cool the air, and we now have a temperature pressure cycle, creating a nice sea breeze. A lot of people, especially in the Med, gets caught out by this sea breeze. They anchor close to the beach in the morning in light or no winds. After lunch and white wine, the wind picks up to a force 4 or 5, and they struggle to get the kids and the anchor on board. In the evening, we get the same cycle, but in reverse. The land cools down faster than the sea, so the sea heats the air, and then the land cools the air, creating a land breeze cycle. One of the key things to remember for the temperature pressure cycle is that the air flows from the high pressure to the low pressure. The wind doesn't just move from a high pressure to a low pressure, it also rotates around a high pressure and a low pressure due to something called the Coriolis effect. Let me explain. Because of the Earth's rotation, winds don't go in a straight line. Different part of the Earth rotates at different speeds. Earth rotates faster at equator than at the poles. Because of this, the wind will curve, causing the winds to rotate clockwise around the high and counterclockwise around the low in the northern hemisphere. In the southern, it will be opposite. The Coriolis effect affects weather patterns, ocean currents, even airplanes. In the northern hemisphere, the Coriolis effect gives us the global winds, like the northeasterly trade winds that take sailors from Europe to the Caribbean for Christmas, and the prevailing westerlies that takes them back to Europe later in the year. The westerly winds are not stable like the trade winds, which is mainly due to the jet streams. The jet streams are high-speed conveyors of wind and can reach speed over 300 kilometers per hour. The major jet streams are the polar front and the subtropical jets. These occur in both the northern and southern hemispheres and are part of the global circulation system. The polar jets occur over mid-latitudes, blocking and shifting high and low systems over the North Atlantic, driving depressions towards different regions affecting the wind and the weather. The polar jet is moving like a snake, north and south. The air accelerates around the bends, which can cause the development of a low or a low to deepen further. If we know what type of air mass the wind is bringing, then we can roughly predict the type of weather we will get, any way the wind blows. There are four categories of air masses. Continental, these are dry, coming from land sources like North Africa, Central Europe, continental polar region, or the desert of Mexico. The second category is maritime air masses, which is moist air coming from areas over water, like the Atlantic, Greenland, and the Arctic seas. Both continental and maritime air masses can be warm or cold. Warm air masses are called tropical, arriving from the South Atlantic or the desert of Africa or Mexico. Cold air masses are labeled polar. They come from the polar region, Greenland and Siberia. When it comes straight from the north, we call it an Arctic air mass. The tropical maritime air masses is warm, moist, and bring clouds and rain and mild weather to the UK. In the spring, these air masses can give a lot of sea fog when the clashes with the cold waters of the English Channel. This is the bathroom situation again. Warm, moist air meets cool water, and it cools and condenses. The same phenomenon with sea fog is seen in Maine and Nova Scotia when the tropical maritime air masses reaches the cold Labrador Current. Hence, it's a very good idea to have a radar on board and know how to use it if you're going early spring sailing in these areas. Tropical continental is hot and dry air masses that brings hot and sunny weather to the UK in the summer. In North America, the tropical continental air masses are only seen in the summer. The air masses are quite unstable at low level, and there can be the occasional thunderstorm in the late afternoon, but the precipitation evaporates before reaching the ground. The polar continental air masses can give us a breath of fresh air in the summer. In the winter, the cold air can bring snow to the UK. We call it the beast from the east. The cold and wet polar maritime air masses will bring cold and showery weather to North America and the UK. So now that we know what type of air masses the wind is bringing, we can roughly predict what type of weather we will be getting. Let's have a look at sources of weather forecast. These days, most people are using apps on their telephone for weather forecasts, but it's a good idea to check with other sources like radio or TV. Or even the marina office can add local experience to your weather forecast. At sea, we can get weather from the Coast Guard on our VHF, and if we are further offshore, we use the NavTech. Of course, weather forecasts are also available on the internet. No matter your source of weather forecast, it is important to understand the terms and definitions in the weather forecast. Let's have a look at that. Most countries will have an inshore weather forecast for small craft vessels. This is the UK inshore forecast. It is issued 4 times a day and it comes with a strong wind warning when the wind is more than force 6. It's called the Yachtman scale. The weather force gives an overview of the general situation and a forecast about wind, sea state, weather, that means rain or snow, and the visibility. When there is a strong wind warning, the coastline of the affected area will be red. Two of the most important aspects to remember about weather forecasts are the period that they are valid for and the time they are issued. In the weather forecast, any timings will be from the time of issue, not when you see or hear the forecast. Forecasts use the following terms for time. Imminent is within 6 hours, soon is 6 to 12 hours, and later is more than 12 hours from the time of issue. In the UK, for the high seas and offshore sailing, we have the shipping forecast, giving a general synopsis and weather forecast for 31 sea areas around the British Isles. It also issues gale warnings for force 8 or above winds. Gale warnings are valid from the time of issue. A small passage planning tip here. If you're planning a passage across the English Channel in sea area Plymouth, it is a good idea to look to the west to see what's going on in the sea area Seoul, Farstad, and Shannon, because the weather systems are moving from west to east. That means during your passage, what's happening in Seoul is going to move in towards you. I already mentioned force 6 and force 8 a few times. These are wind speed according to the Beaufort scale. The Beaufort scale was made donkey years ago at the time of Lord Nelson by Admiral Beaufort to assist the young officers in assessing when to reef, that means making the sails smaller. We also talked about Yachtman scale, when the wind gets to force 6 or force 7 and the going starts to get rough. If you're not already out there, then it's time to consider if you really need to go. Especially if you have to beat, that means sail close to the wind. A force 6 is hard work for little gain. Sea state. It is so important that you check the sea state in the weather forecast. Wind we can handle by making our sails smaller, but sea state can make your passage very uncomfortable. In the weather forecast, you have to take into account that the sea state definitions are made for big cargo vessels. I take a lot of you had been out sailing in moderate seas, finding it quite rough. Also, modern yachts are wider and flat bottom, tends to slam into the waves, making it a very uncomfortable passage. So always check the sea state. It's gonna make your cruising safer and a lot more enjoyable. The weather forecast will also talk about what type of weather we can expect. That means showers, rain, fair weathers, or thunderstorms. An important part of the weather forecast is the visibility. That means how far we can see at sea. Good is more than 5 miles, moderate is 2 to 5 miles, and when it starts to get down to poor or foggy conditions, then you have to start thinking about whether or not to stay in port. Because going into a shipping lane like the English Channel in foggy conditions can be very dangerous. Before we finish with weather forecast, we'll have a look at the terms used for wind. The first term is the wind direction. That's where the wind is coming from: north, south, east, or west, and so on. The next term is variable. Variable winds means light and variable winds from different directions. We know usually experience variable winds in high pressure areas like the Azores High or in the doldrums. If the weather forecast says that the wind will be veering, it will turn clockwise, for example from west to north. If the wind is expected to be backing, it means they will turn anti-clockwise, for example from east to north. If the wind is becoming cyclonic, it indicates that there will be a considerable change in wind direction across the path of a depression within the forecast area. Before I give you a good framework to become a better weather forecaster, we're going to have a look at types of clouds. There are so many types of clouds and cloud definitions that it can be quite mind-blowing trying to figure it out. However, we only need to remember 6 terms. With these 6 terms, we can build up the majority of the clouds. Let's have a look. The 3 main types of clouds are cumulus clouds, which are heaped, lumpy, fluffy clouds. Then we have stratus, which is layer or flat clouds. Then we have cirrus, which are high whispery clouds high up in the sky, which are mainly ice particles. So the next thing we do is to add a height characteristic. Cirro means high level. So cirrocumulus is fluffy, high-lying clouds. Alto means mid-level. So we have altostratus, which is a layer of clouds lying at mid-level. The final addition is nimbus, which means rain or snow bearing. So a cumulus nimbus cloud is a fluffy, rain-bearing cloud. So with these 6 terms, we can describe the majority of the clouds. High-level clouds, like the cirrus cumulus clouds, is a lumpy layer of clouds, also known as macro sky, which we see ahead of a depression. Then we have the medium-level clouds, termed alto, and the low-level clouds, like the stratocumulus clouds, or the nimbostratus clouds, which are a layer of rain-bearing clouds. There is so much weather information available on our phones that sailors are becoming more and more dependent on data. True for both beginners right up to experienced sailors. If you want to get a better understanding on what's driving the weather for that day, then it's time to look up for your phone. Get yourself a cup of coffee. Get outside or on deck. Have a good look around what's going on. Is it raining? Are there any clouds? If so, what direction are they coming from? If you are moored overnight or anchored somewhere sheltered, then the wind you get around the boat has nothing to do with what's happening outside at sea. However, the clouds are at height way above land, so they will give you a best indication of what's happening outside. Now you can go back to your phone, look up the synoptic chart, try to find out where you are in the weather system and what's driving the weather for the day. Another cool tip here is to look at the satellite image or a rain radar. If you bring that up and hold it over the synoptic chart, you will see that the rains are falling along the weather fronts. Let us know in the comments which topic we should cover next. See you at the high seas.